Hello students, once again welcome you to GK's maths classes. Today in continuation with Maxima Minima, this is a part 4 video in Maxima Minima. We are going to solve more problems and word problems. They are very important, likely to come for 5 marks, and even a case study question can come from Maxima Minima. Okay, so let's straight away get inside the problem. The basic and introduction of Maxima Minima I have given in part 1, which I will put in the description box for your reference in case you want to refer. Okay, so now let's straight away go to the problem. This is the first problem. It's a very important question. It's a little lengthy also. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume. So here what is given? Here the surface area is given surface area, and it has maximum volume. You have to maximize the volume. So let's take a diagram. Like this is a cone. Okay. Now what is given to you? It is given that the surface area is given to you. So what is surface area of a cone? So surface area of a cone is pi r L plus pi r square. Call this as 1. So here S is a constant, because that is what is given to you. Surface area is given to you, therefore S is a constant. Everything else is a variable. Now what I should do? I should maximize or minimize? I should maximize the volume of the cone. So what is volume of a cone formula? The volume of the cone will be 1 by 3 pi r square h. 1 by 3 pi r square h. And clearly you can see it has more than one variable. It has r and it also has h. Now I have to change it to a single variable. Now how do I change it to a single variable? I want to get rid of this h. Why I want to get rid of h? Because my s is in terms of only r and l, so h is not required for me. So what is h? H is nothing but L square minus R square. I am using Pythagoras theorem. Okay, but still you have two variables. You have R and you have L. So I will substitute for L. What is L? L is nothing but S minus pi R square divided by pi R. This is from 1. You see, L is nothing but S minus pi R square divided by pi R. So I am going to substitute here. This is pi by 3 r square into root of S minus pi r square, the whole square, divided by pi square r square minus r square. Okay. Now my volume V is pi by 3 into r square into root of, I open the bracket, I get s square minus 2s pi r square plus pi square r power 4. When I take LCM, I get minus pi square r power 4 divided by, when I take square root of pi square r square, I get pi r. Okay. Now you can see pi square r power 4, pi square r power 4 gets cancelled. R and R gets cancelled. Pi and pi gets cancelled. And I want to get rid of the square root. So what I do, as usual, like the previous video I have shown, I take V square as k and I'll write what k is. What is k? R square by 9 into s square minus 2s pi r square. Okay, now I can differentiate, but it's better to open the bracket so that you can avoid product rule. So what is k equal to? 1 by 9 into s square r square minus 2s pi r power 4. I just opened the bracket. Now I'm going to differentiate. I'm going to differentiate with respect to r. So I get 1 by 9 Now what is differentiation of s square r square? S square is a constant. Keep it as it is. Differentiation of r square will be 2r minus 8s pi r cube. 8s pi r cube. I am differentiating r power 4, that is 4r cube. Now I want to find the critical point. So I will find dk by dr equal to 0. So I get 2s square r equal to 8s pi r cube. Now clearly you can see s gets cancelled, 2 gets cancelled, r gets cancelled. So I get s is equal to 4 pi r square. I got s is equal to 4 pi r square. Now I want to do second derivative. D square k by dr square to establish maxima or minima. So I am going to differentiate this. 1 by 9 into 2s square is a constant and differentiation of r is 1 minus 8s pi, differentiation of r cube will be 3r square. Okay. So this will be 1 by 9 into 2s square minus 8s pi 3. What is r square? R square is s by 4 pi. This one, s r square is s by 4 pi. So 4 pi gets cancelled. So what are you left with? 1 by 9 into minus 4s square, because you have 2s square minus 6s square is minus 4s square. So it is negative. Therefore k is maximum when s is equal to 4 pi r square. If k is maximum, v square is maximum. If v square is maximum, what is maximum? V is maximum when s is 4 pi r square. But I want to prove sine inverse of 1 by 3. Semi-vertical angle is sine inverse of 1 by 3. So, but what is s? S from 1, s is pi r l plus pi r square, which is equal to 4 pi r square. So from this you get pi r l equal to 3 pi r square. Now clearly pi gets cancelled, r gets cancelled. So I am left with r l equal to 3r, l equal to 3r, and therefore r by l will be 1 by 3. R by L will be 1 by 3. Now look at the diagram. This is the height and this is the radius. So this is R, this is H, this is L, and this is the semi-vertical angle. From this, what is sine alpha? Sine alpha is opposite by hypotenuse. So if you equate these two, you get sine alpha equal to 1 by 3. So clearly alpha equal to sine inverse of 1 by 3. Very clear, isn't it? Very simple problem, but it is little lengthy, but it is not difficult. Okay, I hope this is clear to you. Now let's go to the next problem. Now here, this is again an NCERT question, and it's a very important question. Now what is the question? A point on the hypotenuse of a right angle triangle, is at a distance small a and small b from the sides of the triangle. Show that the minimum length of the hypotenuse is given there. Okay, so let's go one slowly and check what is given. First of all, you have given a right angle triangle. So this is a right angle triangle. Okay, a point on the hypotenuse. So I have to choose a point on the hypotenuse. So I am choosing a point P on the hypotenuse such that it's always at a distance A and B from the sides. So what I do, I find the distance. So if this is A, so then this is B. So if I choose this as A, then this will be B. Or if I choose this as A, this will be B. Now the question is simple. It's a right angle triangle given. I choose a point P. Wherever I want I can choose. But wherever I choose, it should always be at a distance small a and small b from the sides. That is given to you. So that means A and B are constants. Okay. Okay. Now I have to minimize what? I have to find the minimum length of the hypotenuse. So I have to minimize the hypotenuse. So first what I do, I just name it. A, B, C is a right angle triangle, and I call this as M, and I call this as N. Now what is area of a triangle? Length of the hypotenuse, right? So what is length of the hypotenuse? Length of the hypotenuse is nothing but AP plus PC. You see? Length of the hypotenuse, AC is nothing but AP plus PC. I have to minimize this length L. Okay, I have to minimize this length L. Now further what I do, I am going to use trigonometry. I will take angle BCA as theta. Okay. I am letting angle BCA to be theta. So that means this is theta. So if this is theta, obviously this also will be theta, right? I think something happened. Okay. Now, obviously, angle MPA will also be theta. Why? Because MP and BC are parallel. So this is also theta. Now first what I will do, I will take triangle PNC. I want to find PC, right? And I know B, opposite I know. So I will take cosecant theta. So what is cosecant theta? Cosecant theta is PC, hypotenuse, by opposite. Hypotenuse by opposite. Now I take triangle AMP. I want to find PA. So I will take secant theta. Secant theta will be AP by A. Hypotenuse by adjacent. Okay. So now take all this and substitute it. What is L? L is nothing but what is AP? AP is A secant theta. And what is PC? B cosecant theta. Job done. Simple. Okay. Now only theta is a variable, A and B are constants. Now I differentiate dl by d theta. How do I differentiate? A into differentiation of secant theta will be secant theta tan theta, and this will be minus B cosecant theta cot theta. Okay. Now I am going to equate it to 0. I am going to find the critical point. I will get A, this is sine theta by cos square theta. How did I get that? Tan is sine by cos, secant is 1 by cos. So you get sine by cos square theta equal to B into cot theta is cos theta by sine theta. Cosecant, there's already one more sine, so it is sine square theta. If you cross multiply, I get sine cube theta by cos cube theta equal to B by A. So obviously tan cube theta equal to B by A. So what is tan theta? Tan theta is B power 1 by 3 by A power 1 by 3. Something very, very important. See, I brought the hypotenuse AP and PC in terms of theta using trigonometry. I differentiated, equated to 0 and found theta. Now I have to go for second derivative to establish whether it is maxima or minima, right? So I'm going to differentiate this. D square L by d theta square. Now A is a constant. I keep it inside. I'm going to use product rule for secant theta into tan theta. What is product rule? U into, and differentiation of tan will be secant square theta plus tan theta into, differentiation of secant theta will be secant theta tan theta, I close the bracket, plus B into, I'm going to minus B, sorry, minus B into, I'm going to use again product rule. What is that? Cosecant theta into, what is differentiation of cot? Minus cosecant square theta plus cot theta into, what is differentiation of cosecant theta? It is minus cosecant theta cot theta. Close the bracket. Now here what is common? Secant is common. So I'll take it outside. It's A secant theta. What do you get inside? Secant square theta plus tan square theta. Here in both the terms you have minus common. So if I take it out, it becomes plus B. Not only that, cosecant is common, so I'll take that also out. So I get cosecant square theta plus cot square theta. Now clearly you should understand that it is a right angle triangle and theta will be acute. Since it is a right angle triangle, theta must be less than 90, otherwise they can form a triangle. So since theta is acute, acute means less than 90, so it is first quadrant. Okay, so first quadrant, secant, cosecant, secant square, tan square, all are positive. So you can say this is greater than 0. I hope you understand that. Theta is acute. Why it is acute? Because this is 90 means definitely this should be less than 90. If this is less than 90, then it is in the first quadrant. In the first quadrant, all the trigonometric ratios are positive. Therefore, this is obviously positive. Since it is positive, L is minimum. That is what I wanted to prove. L is minimum. When is it minimum? When tan theta is a power 1 by 3, b power 1 by 3 by a power 1 by 3. So I have got here. Now I have to find the minimum length of the hypotenuse. So what's the minimum length? Minimum length L is, I use this, A secant theta plus B cosecant theta. A secant theta plus B cosecant theta, correct? A secant theta plus B cosecant theta. For that what I do, I take a right angle triangle. Watch this carefully. This is theta. Tan theta is B power 1 by 3 by A power 1 by 3. Now if I use Pythagoras theorem, I will get this will be root of A power 2 by 3 plus B power 2 by 3, correct? X square plus Y square. I am just using Pythagoras theorem. Now L is A into, what is secant? Secant is hypotenuse by adjacent. So what is hypotenuse? Root of A power 2 by 3 plus B power 2 by 3 divided by A power 1 by 3 plus B into, what is cosecant theta? Hypotenuse. What is hypotenuse? A power 2 by 3 plus B power 2 by 3 by B power 1 by 3. Correct? Now this is L equal to, these two are common, so I will take it out. A power 2 by 3 plus B power 2 by 3. So what do you get inside? A power 1 by A power 1 by 3 is A power 2 by 3, correct? 1 minus 1 by 3, that is 2 by 3. And this is B power 2 by 3. This is to the power 1, okay? But you know, x root x is x power 3 by 2, correct? So this is your x and this is your root x. What is that? This is nothing but A power 2 by 3 plus B power 2 by 3 whole power 3 by 2. This is exactly what you wanted to prove. The minimum length of the hypotenuse is a power 2 by 3 plus b power 2 by 3 the whole power 3 by 2. Lengthy problem, it is slightly difficult. If you use trigonometry, it becomes much easier, okay, compared to any other method. Okay, now next go to the next question. This is also equally very important question. Watch this carefully. Okay, today these problems are lengthy and also difficult. Okay, find the maximum area of an isosceles triangle that is inscribed in an ellipse with one of its vertex at one end of the major axis. Okay, so for that what I do, first of all let me draw the coordinate axis. Okay, let's keep it simple. Okay, now let's draw an ellipse. Okay, this is the ellipse. Okay, to some extent we have drawn the ellipse. Okay, now this is the major axis, this is the minor axis. I think you know all that. Okay, and now I have to enclose an isosceles triangle. So let's draw an isosceles triangle. So I'll just copy this. So how do I draw the isosceles triangle? One vertex is on the major axis. See this? This is an isosceles triangle. Isosceles triangle that is inscribed in an ellipse such that its vertex, one of the vertex, this vertex, coincides with one end of the major axis. So this one vertex is on the one end. It has two ends for major axis, but one vertex and major axis, they will coincide. That is how I have drawn. Okay, so let me name this as I'll name this as A, and I call this as B, and I call this as C. O is the center of the ellipse and D is the perpendicular. Okay, so everything is finished. Now I want to maximize the area, right? So what is, you remember everything about the ellipse is a constant. Here ellipse is a constant. Don't forget, ellipse is a constant. Now what is area of the ellipse? Area of the isosceles triangle, half into base. Base is BC and the height is AD. Half base into height. Half base into height. Correct? So now, how do I go about it? Remember, this is an isosceles triangle. Here AB equal to AC, and this is a perpendicular. By the property of isosceles triangle, clearly BD equal to DC. BD equal to DC. Okay, BD equal to DC. Don't forget that BD equal to DC. Okay, now let us choose this point as x comma y. I'll choose that point as x comma y. Now what is OA? OA is length A. It's a half of the major axis. The total major axis is 2A. So OA will be half of major axis, so it is A. Remember, this is 2A. 11th standard we studied. This is 2A. So this will be A. And what is OD? OD is X. It's a X coordinate. Okay, OD is X. So what is AD? AD is A plus X. And what is BD? BD is y. Therefore, what is BC? BC will be 2y. Okay, simple, very simple. BD is y, so BC will be 2y. So what is area? Area will be half into, what is BC? BC is 2y, and what is AD? AD is A plus x. Okay, so 2 gets cancelled. So what is area equal to? A plus x into y. A plus x into y. So that is also clear to me. A plus x into y. Now what is y? Look at the diagram. Look at the equation. You have y square by b square equal to 1 minus x square by a square. So if I take LCM, I get a square minus x square by a square into b square is my y square. So what is my y? My y will be a plus x into y will be what? B by a into root of b by a into root of a square minus x square. Y square is this, so y will be b by a into root of a square minus x square. Okay, but as I told you, square root is a problem, so I call it as k. So what is k equal to? B square by a square into a plus x the whole square into a square minus x square. You see, a plus x the whole square, a square minus x square. I just further simplify this, which is b square by a square into, this is a plus x the whole square into a minus x. I am using a square minus b square, so this will become whole cube. Okay, now everything is done. I am going to differentiate. Okay, how do I differentiate? So dA dk by dx. dk by dx will be b square by a square. B square by a square. I am going to use product rule. What is product rule? It is a plus x the whole cube, and differentiation of a minus x is minus 1 plus a minus x into, what is differentiation of a plus x whole cube? It is 3 into a plus x the whole square. Correct? Now what is common in this? B square by a square into a plus x the whole square is common. So I'll get minus a minus x. I'm multiplying this minus sign also, plus 3a minus 3x. 3a minus 3x. Now I find the critical point. dk by dx equal to 0. So I get x is equal to minus a, which is invalid, or otherwise I'll get 2a. See here, this is 2a equal to 4x. So x is equal to a by 2. X is equal to a by 2. This is invalid. Okay. Now I want to differentiate again to check whether it is maximum or not. D square k by dx square. What is that? B square by a square is common. Now I am going to use product rule for this. So it is a plus x the whole square. Now how do I differentiate this? This is nothing but minus 4. Why? Minus 4x differentiation is minus 4 plus 2a minus 4x, 2a minus 4x. Differentiation of this will be 2 times a plus x. Okay. Now substitute x is equal to a by 2. When I do that, what do I get? I will get, this will be minus 4 into, if I put x as a by 2, you get 3a by 2 the whole square plus 0. This entire thing will become 0. And obviously this is negative. If it is negative, what do you say about k? K is maximum when x is a by 2. Correct? If K is maximum, what is maximum? A square is maximum, therefore A is maximum, right? So I'll go to the next page. So A square is maximum, or you can say A is maximum when x is A by 2. Okay? Now I want to find the maximum area. So what I will do, I will substitute here. Look at this. I'll take this there. So what is area? So the maximum area is A equal to B by A into A plus A by 2 into root of A square minus A square by 4. So this is B by A into 3A by 2 into root of 3A square by 4. So this is A gets cancelled. You get 3B by 2 into root 3A by 2. So if I put them together, you get 3 root 3 AB by 4 square units. Very important question this is. Please understand, I did a problem in a very lengthy way, okay, where I don't have to use trigonometry. If I use Cartesian, if I use parametric equation, if I take A cos theta and B sin theta, the problem will become slightly shorter. But you know, some people have difficulty with trigonometry, so I am avoiding it. So I just use normal algebra. I just use x and y, and I am able to get the answer. Okay. So this is very simple problem, but you need to think and do. You have to be very careful. Okay. But very important question also. Now the next one, the very important sum. Very important sum. Again, this is an NCERT question. Watch this carefully. Show that the height of a cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r by root 3. Also find its maximum volume. So what I will do, first of all, I'll take a sphere. Now just for our understanding, I'll draw the sphere like a circle. This is a sphere. And volume of a, show that the cylinder. So what is inscribed inside? Cylinder is inscribed inside. So I am inscribing a cylinder. So a cylinder is inscribed in a sphere. So here you know very well everything about the sphere. Everything about the sphere is a constant. So here I think he has given capital R as the radius of the sphere. So R is a constant. Okay. Now let me draw the diameter. And clearly the diameter of the sphere, this will be the diameter of the sphere. Why? This is origin. So this is 90 degrees. You can just understand angle in a semicircle is 90 degrees. Okay. So this is capital R. This is capital R. And this is the radius of the sphere. So small r, and this is the height h. Okay. Now I want to maximize the volume, right? So what is volume? The volume formula is pi r square h. The volume formula is pi r square h. Okay, and it will be nothing but 4r square equal to 4r square plus h square. I am using Pythagoras theorem. Okay, now what is volume formula? Volume is pi r square h, and what is r square? 4r square equal to 4r square plus h square. I am using Pythagoras theorem. 4r square equal to 4r square plus h square. Okay. Now what is r square from this? 4r square minus h square by 4. Now substitute. Volume is pi into 4r square minus h square by 4 into h. Now it has only one variable. Here the variable is h because r is a constant. So I open the bracket. So it is pi by 4 into 4r square h minus h cube. 4r square h minus h cube. Now what is dv by dh? dv by dh is pi by 4 into, this will be 4r square, differentiation of h is 1, minus 3h square. Now critical point, dv by dh is equal to 0. We get 4r square equal to 3h square. Therefore h is equal to 2r by root 3. This is what I wanted to prove. Right? 2r by root 3. Show that the height of the cylinder is 2r by root 3. Now I have to show the volume is maximum. So I do second derivative. D square v by dh square, which is pi by 4 into differentiation of 4r square will be 0 because it's a constant. This is minus 6h. Therefore, V is maximum. V is maximum when h is 2r by root 3. That's what I wanted to prove. Now I want to find the maximum volume. So what is the maximum volume of cylinder? I will substitute it here, okay, which is pi by 4 into 4r square minus h square into h, which is pi by 4 into 4r square minus, what is h square? H square is 4r square by 3 and h is 2r by root 3. So this is pi by 4 into, if you take LCM you get 12 minus 4, that is 8r square by 3 into 2r by root 3. 4 gets cancelled. So I am left with C. 1 by root 3, write the remaining, that is 4 by 3 pi r cube. So you got a beautiful result, that the maximum volume of the cylinder is 1 by root 3 times the volume of the sphere. 1 by root 3 times the volume of the sphere. That is what I wanted to find. Okay. Now the last problem for the day. This is again a simple NCERT question. Let's do this quickly. The sum of the perimeter of the circle and the square is given. So what is given? The perimeter of the circle. Perimeter of the circle is 2 pi r and perimeter of the square is 4a, and it is given to be k, and here k is a constant. K is a constant. Now prove that sum of their areas. So sum of their areas. So what is sum of their areas? Area of the circle is pi r square. Area of the square is a square. I have to show it is least, right? Prove that sum of their areas is least. Okay. Now S is equal to pi r square plus, what is a square? It is nothing but k minus 2 pi r the whole square by 16. How did I get that? From here I get 4a equal to k minus 2 pi r and a equal to k minus 2 pi r by 4. That's what I did here. Now I am going to differentiate ds by dr, which is 2 pi r plus power 2 into k minus 2 pi r, and differentiation of minus 2 pi r will be minus 2 pi divided by 16. Normal differentiation. 2 pi r, then I differentiate the power, then the base. Now the critical point, ds by dr equal to 0, 2 pi r equal to 4 pi by 16 into k minus 2 pi r. I take this entire term that side, so minus becomes plus. Now you can see pi and pi cancels, 4 goes 4 times, so I get 8r equal to k minus 2 pi r. But from 1, what is k minus 2 pi r? It is 4a. So from this you got a equal to 2r. This is exactly what I wanted to prove. So that the side of the square is double the radius of the circle. Side of the square is double the radius of the circle. But I have not still established that it is maximum. So I have to do second derivative. D square s by dr square equal to 2 pi, because differentiation of r is 1, minus 4 pi by 16, minus 4 pi by 16. Now I have to differentiate minus 2 pi r. Minus 2 pi r is minus 2 pi. So this is 4 pi plus 8 pi square by 16, which is always positive. Therefore, S is minimum. When is it minimum? When A is 2r. Okay. So we have completed 5 questions. All these problems are difficult. You need to go through it very carefully. If you have doubt, kindly message in the comment section. I will get back to you. I hope these videos are useful to you. Kindly subscribe to my channel and also click the bell icon to get notifications of video that I post. See you again in the next class. Have a lovely day. Bye bye.